Good evening, ladies and gentlemen. Or I guess it's afternoon, not evening. I hope you guys are doing well. It is 4:04 in the PM. Time not found, or insert a funny joke about that here. Anyways, I slept a little bit late, so I woke up a little bit late, and as a result, the stream is a little bit late. So I hope that's not too much of a problem for anybody. Today we're going to be doing some more C++. We're going to be doing some. Let me see. What are we looking at? Today we're looking at resurrecting members back in context and everything beyond that point. So that puts us at the 24-hour mark of our video that is linked in my YouTube description. We're at the 24-hour, 26-minute, and 37-second mark, which I think on YouTube now it says 1 day, 26 hours, and 37 seconds. So that's where we are with that. So from what I understand, what we're going to be doing is if we private something, we're going to be seeing how we can undo that later downstream, is kind of the way I understand it. But as of yet, I don't quite know what the fuck he's talking about. So we'll find out. We'll see. We'll see. It'll be interesting. But I'm hoping to maybe get through a few more sections today. The goal for me, I want to get through resurrecting members back in context, default constructors with inheritance, and custom constructors with inheritance. And man, I don't know. There's so many of them, but we have like 2 hours of this chapter remaining before we're finished with it. So I don't know exactly where it'll be a good place to stop. Because there's like, what is it? We got resurrecting members, then it's default constructors, custom constructors, copy constructors, then it's inheriting base constructors, and inheritance and destructors, and then reused symbols and inheritance. So I'm not 100% on how all that shit's going to work out yet. Don't know. It'll be interesting to see one way or the other. I think what we'll do is we'll just continue the video. I'll probably go for 2 to 3 hours is the objective. We'll be doing 2 to 3 hours of stream today, and then see how far we get through. Whatever section we're on, when I decide that we're done, or when I decided to call it a day, we'll finish that section, and then we'll continue with we'll continue it tomorrow, and hopefully that means that we can do uh hopefully that means we can finish chapter 18 either tomorrow. Well, hopefully tomorrow is the objective. That's the goal. I want to be able to do. I want to finish it. I want to be done with inheritance because for the most part, I think I understand what's going on. All right. So with that, let's go over to. All right. So this is the thing we did yesterday. I don't know if it'll be relevant. I made a bunch of default shit before stream. So we have a few template projects that we can recreate if we need to. I figured since the other ones used this, we might need it, so we'll just do that. So let's do like this real quick, and Gakwaya Sensei, take it away.
In this lecture, we're going to explore how we can resurrect members back in scope. So what do we mean here? Suppose we have our trusty inheritance tree here. We have a base class person. The engineer class is going to do private inheritance, and it's going to really be selfish and say, I am going to take everything I can from the upstream person class, but I am going to make everything my own, and nobody inheriting from me will have access to these guys. For example, M1 and M2 are going to be private to the engineer class starting here when the engineer class does private inheritance. So any other class, for example, civil engineer, which is inheriting from the engineer class in any way, won't have access to the M1 and M2 member variables. So suppose for some reason that we have this kind of setup here. But again, we want some members to be accessible to other downstream classes. Suppose, for example, we want the M1 member variable to still be accessible to downstream classes while we have done private inheritance. C++ is really weird in a way. It is going to work hard to really prevent you to do things and then give you a backdoor you can go through to allow the same thing you were trying to avoid in the same place. It is the same kind of logic we have here. It allows you to use private inheritance to prevent downstream classes to access to anything you got from upstream classes. But then again, it allows you to change that and relax the access to downstream classes. For example, we can change the access of M1 and M2, make it more relaxed, make it public or protected if we wanted that. So let's take a look at some code because I know that these things can really be confusing.
Yeah, this
Okay,
concept
we are
sounds a
going to
little bit
start
crazy
from
to me.
person class.
All right, all right. So we're looking at this. We have our class. I want to try to read through it myself real quick. So we have class person. We have a friend operation that I still don't quite understand how it works. I think it's just that OStream works with it works with stuff within class. It has the same accesses. I'm not 100% on that though. Public. So we have a person constructor, a person custom constructor, and a destructor. So person custom constructor takes a full name, an age, and an address. And we have those things are still here. So this the address should just be this is the private one. This is what we don't know about. Or this is what we're not going to be able to access, supposedly. So I guess the idea is that we're going to be relaxing this or maybe even this one as well. I think the idea is that we can make all of this stuff public later on.
Which is going to have a bunch of member variables. We will also have a bunch of getters that are going to return all these member variables. And we are going to do private inheritance from person in an engineer class. This is going to strip down access to the members we get from person to private level access. For example, the get full name member function, the get age, the get address member functions are going to be private to the engineer class now. But for some reason, you might want to resurrect them to a more relaxed access level. And you do that using the using keyword. So the first thing you need to do is to choose the section in which you're going to be putting these using statements. For example, because we put them in a protected section, all these guys are going to be resurrected with an access level of protected. If we put them in a public section, they are going to be resurrected with a public access level, and they are going to be accessible from inheriting classes. One thing you should know is that you can't resurrect something that is already private to an upstream class. For example, we know that our address member variable was private to the person class, so we can't really resurrect that in an inheriting class.
So that makes sense. If we do that,
we're going to get a compiler error. And hopefully this is going to drive the point home that private inheritance is really, really serious, in that it's going to strip down access to private level access in an inheriting class, and any downstream inheriting class will never be able to resurrect those member variables to a more relaxed access level. So because everything here is inherited as private by default, any downstream inheriting class will never be able to resurrect these guys, for example, to public or protected scope. This is the message here. And you can use this kind of design if you want that. But personally, I don't like to do this because it's going to make your code much more hard to read and understand. If you want these guys to be public or protected, why not make them public or protected in the first place and really not use private inheritance? That's going to be much more direct.
That makes way more sense to me.
And your code is going to be easier to work with for you in the future, or for some other developers that will get to work on your code in the future. So this is the message here. You can use this feature to resurrect members back to a relaxed access level. And now that you have an idea about this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder.
Oh, whoops. Whoopsies. All right.
Current project is resurrecting members back in context. We are going to completely reuse the code from the last lecture because it's going to give us a good starting point. We can copy everything except for the binary here. We don't need that in our current project. We're going to
Look at
put
that.
in our
I'm
starter
prepared.
code, and we're going to open this little guy in Visual Studio Code.
All
So we're
right.
going to have our code, we're going to have our main function, and we're going to have all these objects.
Let me make sure. So we got civil engineer. We got civil engineer. We got engineer. We got main, and then we have person and person, and we don't really need this. Let me actually go into the terminal real quick and what was it? Del. All right, nice. I remembered that from the first lesson. All right.
Created here. I'm really not sure if we're going to need this yet, so let's take this out. And we're going to look at our person class. It is going to have our members here, and we are going to have a bunch of getters which are going to be returning these member variables, and we have a constructor here which is really going to build a person object. Nothing complicated here.
Nothing
we have
complicated.
An engineer class which is going to privately inherit from person, and we know that this is going to eclipse everything that is not private in the person class.
We do know that.
To private level access.
So this is where we're probably going to do the using
private
keyword.
To the engineer class now. But sometimes we don't want to do that. For example, if we go down in our civil engineer class, we're going to see that the get full name and the get age methods are going to be private to the upstream engineer class.
Darn,
and that's going to break
that's
the code
annoying.
For our output stream operator, and it's not going to work because we want to have access to get full name and get age. And that's also going to kill access we had on the get address method, which would give us access to the address member that we have in our person class. Let's make sure we are looking at person. I am confused here. We have a lot of pieces of code here. Where is the person header?
It's at the very bottom.
It is down here. So we have
Yeah.
the get address method, which is going to return the address. We want to have access to that in our civil engineer class to be able to print all this information.
Yeah.
If we also want to,
because as of right now, this is broken.
Count, we can go in our engineer class and put in a method which is going to return that. So we can say int and say get contract count. And this is going to be a const member function because it's not going to be modifying our object. We're just going to return a value. We're going to return the contract count. And we can go in our civil engineer implementation file and change this to say operand get contract count. We can do that. Okay, we have this method now. We want this.
So we'll do change this one to get contract count. Let's get rid of these lines. So these are still broken because those are still private. But the get contract count just needs to be, I don't know why I didn't do it. Like so. And now that works.
This to work. This is going to work because we are doing public inheritance from the civil engineer class, but we want this to work. We want to get full name, get age, and get address to work here. And we can use the using feature to resurrect these members to an access level which will allow our civil engineer class to pick them up. So we can go in our engineer class and set up, for example, a public or protected scope. We're going to use protected because we want these to only be accessible from inheriting classes, for example. So we're going to say protected, and we're going to say using. This is the syntax. We're going to say person, and we're going to say get full name. We're going to say using person, get age. We're going to choose this, and we are going to say using person and say get address. I think we have that method here. The moment we do this, we're going to go in our civil engineer class. You're going to see that it is going to work now because what we just did is resurrect these members to have protected access level in the engineer class.
Okay, let's see. So now it should be the civil engineer one, and yeah, looks like all this stuff works. I'm kind of curious. Is this one still broken? It's not. That's pretty cool. We were in the correct. Yeah, all of this stuff is going to be. It should work, right?
So the inheriting classes are going to look at this and see that they have a protected access level in the engineer class, and they are going to be forwarded down to any inheriting class. We could also change this to public. This is also going to work. They are going to be inherited as public, and hopefully you can see that any member that you resurrect, it's going to take the access level of the section where you resurrected. If we resurrect them in a public scope, they are going to be resurrected with a public access level. If we resurrect them in a protected scope, they are going to be resurrected with protected access level, and this is the message here. Now, if you happen to have a bunch of overloads in an upstream class, for example, suppose we have a bunch of add functions in the person class, we can go in and put in, let's do that. We can go down and say double or int, let's say int. So that's going to be much simpler. We can say add and say int A and say int B and say int C. We're going to have three things that we are adding. This is going to be a const member function. It's not going to be modifying our members in any way. So we're going to return A plus B plus C. This is something we can return from a member function here. And we're going to do an overload of the add member to do the addition of two parameters. So we're going to only have A and B, and I think we can use A and B in the first overload here. That's going to be much easier to follow. So we have one that adds two parameters, and we have another one which is going to add three parameters. If we privately inherit from person, these guys are going to be stripped down to private level access in the engineer class, and they won't be accessible from in any other downstream class. So for example, if we head over in our civil engineer class and trying to say add 10 to 2, for example, we're going to get a compiler error because we don't have access to this. But
okay, so civil engineer. So this one was part of the build road thing. That's what, add 10 to. So this one does not work. This method is inaccessible. But if I'm going to assume it shouldn't work for the other one either, right? Yeah, because all of them, because they're both stripped down, I think is the phrasing he's using, to private, so that they can't be accessed by anything else because it's inherited as private. Interesting.
we can also resurrect these add members in our engineer class. So let's go there, and we're going to set up a public section in this class here, and we're going to say using person add. This is going to resurrect all the overloads that we have in our upstream class.
Oh, it'll do both of them?
This is going to be the
I guess that makes sense.
We resurrect only based on the name of the function, and the same name for a member function can be shared by many overloads. So if we do this kind of resurrecting, we are doing for the add member function from person, we are going to get all the overloads. If we go in civil engineer,
yeah, you can
we
do
will
both.
be able to use the member function taking two parameters. We will also be able to use the one that takes three parameters. They are all going to be resurrected here. This is the message I want to convey. If we do this, you're going to see that this is going to work, and our code is going to just build fine. Let's build and see if the build is good. Actually, we're going to pass this through GCC. The build is going to be good, so everything is working just fine. And the message I really wanted to convey is that it is possible to resurrect members in a more resurrected access level if you are inheriting using a really constrained base class access specifier. For example, we are inheriting using a private access specifier. This is going to eclipse everything we get from the upstream class to private level. But if you think that's too much and you have a few members that you would like to put in a more relaxed access level, you can use this resurrecting feature, and it is going to make things accessible in downstream classes if that's what you want in your program.
See, okay, this kind of I like this syntax because it kind of makes sense to me. Because it's basically all it's what it's doing from based on the way this syntax looks to me. What it seems to be doing is it's using the person scope to get the full name. So when we go into person, right, it's using this get full name. So you're able to get the full name. It's using this get address so that you can get this address. Because it's like it's using this thing's scope in order to uh do to do its fucking to do the method that you have given it, which I think is really cool. Um, I'm wondering now. This is probably something to do with polymorphism, if I'm not mistaken. But I'm wondering now if it's possible to do this across different um different objects, different classes. Like if I create class person and then I have like I don't know class like shape or something. Can I go into something from person and then like I don't know, get vertices, get angles or some shit like that for the shape in the using the scope of shape? I imagine not, at least not directly. There's probably some workaround for it or some shit, but that's kind of what I'm wondering now because I think that having classes being able to interact in that way I think would is kind of an interesting idea. I haven't confirmed whether it's even possible at this point, but yeah, cool.
And again, I hope this drives the point home that C++ is going to sometimes work really hard to prevent you from doing one thing and then again give you a back door you can go through to do that same thing. This is the same thing here. We are doing
This
private
is
inheritance, but we are allowed to kill or relax the effects of private inheritance by bringing things in a more relaxed access level. And you can use this if it makes sense for your code. Again, I don't like this personally because it's going to make code confusing.
yeah, it
If
seems
other
very
developers see that you are doing private inheritance, they are going to expect everything from the upstream class to be private to the class that is doing private inheritance. And if they see that they can use these things that should be private by default in downstream classes, this is really going to confuse them, and it is going to cost them more minutes to look at your code to really understand what is going on. So if you really want these things to be accessible in downstream classes, why not do public or protected inheritance in the first place? This is my
I kind of agree with him. Like I'm kind of this kind of makes sense to me to complain about. Oh, I'm actually kind of curious. I assume that this works. I assume this will work, but what if I do? I just had an idea. What if I did like this, but then I went to here? It was this one, right? We have it. It is protected. This stuff is protected. Oh, actually, wait a second. Am I an idiot? So this is protected. Yeah, okay. So yeah. For some reason, I blanked that we were doing civil engineer, and that is downstream of engineer. But this, if this is the way that it is in engineer, then this stuff should obviously, if it works in civil engineer, it should definitely work in engineer. so I'm not super concerned about testing it. But I am kind of I am kind of confused as to why you would ever choose to, hey, we're going to inherit privately, but then we're going to have our use our we're going to using we're going to resurrect our member uh later on. It seems like the kind of thing that it maybe there's a reason that you would want you I could conceive of a reason where you would do or where you would want something that accessible to both person and civil engineer, but not to, I guess, maybe not engineer, but like some intermediary between the you would I could see a reason where you would want the base class and like a fourth derived class to have a number accessible, where you wouldn't want the third one for some reason. I could maybe see a system like that, but like that seems like I don't know how often are we deriving classes like that? Like I mean, at least for like if I'm thinking it's like maybe like video game enemy types. If it's like a enemy and then a flying enemy is derived from enemy, and then like multiple types of flying enemies get derived from the same scope. I don't know. That seems like a stretch too. I have no idea why you would want to do this. It seems very extra to me. Like I feel like you could just inherit inherit as protected if you're like kind of worried about outside stuff messing with it, and then that means that only stuff within that class stream can do it. Because like in this case, like engineer is downstream of person, civil engineer is downstream of engineer. Maybe fucking road worker or some shit is downstream of civil engineer. Like shit like that. Very where it's like, hey, this inherits this, or some shit. I don't know.
My argument here, but it is going to be your choice. My job here is to make you aware of the possibilities that you have in the C++ programming language. Okay, the last thing I want you to see in this lecture is that if there is something that was already private in an upstream class, you can't resurrect that. If you try to do that, you're going to get a compiler error. This is also going to drive the point home that you can also resurrect member variables. So far, what we have only resurrected was all member functions, and we can also resurrect.
Wait a second. What was that? I was like half paying attention.
Resurrect. If there is something that was already private in an upstream class, you can't resurrect that.
If it was private in an upstream class, you can't resurrect that. Is that not like the whole point of what we were doing? Like like engineer can't get address, but now because we used person scope of engineer, we can. Is it one of those things where it's like it has to be directly up one? Let me see. If I hold on, I'm gonna do a little bit of. I'm just gonna copy this, and we're gonna go to civil engineer, and we're going to do like this. Now, I'm pretty sure if I get rid of this, actually, let me, was this one? There. So I'm pretty sure if we get rid of that, now this shouldn't work. Does this still work? Okay, it doesn't. It doesn't. Okay. I was about to be confused. Okay. Uh, class person is private within this context. Person get full name. Yeah. Okay. Yeah. Okay. Person is a private member of person. Okay. So it yeah. It can't go too upstream by the looks of it. It seems like it can. And this one should still be broken because this thing. So now we should be back to being able to run. Okay. Yeah, so we aren't able. So from what it seems, what it seems like he means in this case, and I'm not sure if this is 100% correct. What it seems like he means is that you can't like skip one up. Like civil engineer cannot access, can't do the person this deal. We aren't able to do this by the looks of it. Because even though we had the thing before as well, let's try it just like this. Okay, so these don't work. It says it's private within this context. So engineer inherits person privately, and as a result, none of this stuff is accessible to downstream classes. That's kind of interesting. We are able to use. We can use person to get address even though the address is a private member variable in person. We can use the scope of person in the engineer class. But because we've inherited, I think because we've inherited privately, here, let me do, if I do protected here, does this let this thing work? I'm going to bet no. No, it does. Okay, so it is because we've done it. Person is a private member of person. Yeah, that's fine. So because we've inherited privately, in we've in the person class. So let's do private again here. So this should again be fine. Terminal run task. Good. So because we inherit this one. Engineer inherits person privately. We are not able to do any of this stuff as a civil engineer, which I think is kind of. I mean, it's kind of difficult to keep track of, but it definitely is interesting to think about, I think. Um, in the meanwhile, yeah, no, I mean, I guess that just makes sense to me. Yeah, let's continue.
If you try to do that, you're going to get a compiler error. This is also going to drive the point home that you can also resurrect member variables. So far, what we have only resurrected was all member functions, and we can also resurrect member variables. So we're going to try and resurrect the address member in the engineer class, and let's see how this works out. So let's go in our engineer class. We can go in our protected section. We can do this really in any kind of section. We're going to say user, and we're going to say person, and we're going to say address. You see that this is not going to be available in autocomplete. This is going to be assigned that this is.
Oh, am I an idiot? It's because these are public that we're able to do the engineer stuff. And then when we inherit them, Okay. So we aren't able to actually access... We can't do this for private member variables. Okay, I'm understanding now. We aren't able to do these for private member variables. We can access age in public because engineer inherits those, but because person was is a private member variable, we aren't able to resurrect it. That kind of begs the question of what the fuck the point of this is then, to me. How goes the war? It goes ever so slowly. I started a little bit late today. Didn't manage to sleep for a long time. Protected. Uh fucking... Okay, so what I was uh before I fucking got stun locked by my own brain, fucking I I don't understand how or what the purpose of doing it this way is. Like we can't... So the address is private in the person class, and we can't resurrect it in the engineer class. I assume... What was that stun lock? You literally sounded like you had a PTSD attack. I don't know, man. I was like trying to form a sentence, and then I was trying to talk, and I couldn't figure out what I was trying to say. Basically, so because we aren't able to access these fucking... What are they? The private member variable in engineer. I'm kind of confused as to why you would bother doing any of this using stuff at all. I mean, it's just... It doesn't work, obviously. But then, is it just because if we have something that is from here that becomes private, we can then use it for this one? It just seems very... It seems so extra to me.
It's going to give us a compiler error. And if we're trying to do that, we're going to see that we're going to get a compiler
I'll
error.
say,
The
what,
message
private within
here
this
is
context,
that if
inaccessible?
something is already private in an upstream class, you can't resurrect it. It
Inaccessible.
is eclipsed down forever. And hopefully this drives the point home again that private inheritance is really serious. For example, in our civil engineer class, we can't resurrect something that was already eclipsed to private level access by the engineer class. Let's go in our person class and see if we have any other member function we can play with. We're going to put in a member function that says do something. We're going to say void do something, and it's going to be const. It's just going to say hello. We can do something like this. We are learning. And this method is going to be eclipsed down to private level access because we are doing private.
What was it? It was just hello. Let's see out. Hello. STD end line.
To be eclipsed down to private level access because we are doing private inheritance from person. Let's go back in our engineer and comment this out because it is going to give you a compiler error. If you build, you're going to get a weird compiler error. I think I should really show you this because we are learning here.
I mean, it's just
So we're going
inaccessible,
to
isn't it? We've seen it before.
Anyway, we're going to pass
Am I
this to
crazy?
GCC, and we're going to see the kind of compiler error we get. And we are going to see that there's no member std. This is a problem we just introduced in our class here. I think to solve this problem, we can just put our definition in the CPP file. We can do that. We're going to grab this and we're going to put the definition in person.cpp because we have IO stream included in there. This is going to make our code work much better.
Wait, did it just... That hello thing that we just did that break his code? Wait. This one? Oh my god, I don't remember where we put it. Am I missing something? Does mine not build? Huh, I guess not. No member named cout in namespace std. Cout is not a member of std. What? What? Okay, that's interesting. I have no idea why that is the way that it is.
Let's do this. We're going to say void and say person, and we're going to say std out hello. This is going to fix our problem here. And the only problem we will have will be in engineer, where we are trying to access things that are now
Am I going crazy?
near, and say to make that do that. We're going to put our definition in the CPP file. We can do that.
We're just leaving this here.
To grab this, and we're going to put the definition in person.cpp because we have IO stream included in there. This is going to make our code work much better. Let's do this. We're going to say void and say person, and we're going to say std out hello. This is going to fix our problem here. And the only problem we will have will be in engineer, where we are trying to access things that are now private to the base class. Why do we have this squiggly line here?
let me try running this, make sure he actually fixed the problem. I think he did. Yeah, okay. That was weird. I don't think I've ever encountered that before. Has no member cout. Huh.
Let's take out this and try to build, really make sure that this problem is not existent. And it was Visual Studio Code messing with us. So we're going to bring this in and build, and we're going to see the kind of compiler error we get here. This is what I am trying to make you see. You see the build is finished with errors. If we go back, we're going to see that string person m address is private within this context. We can't really resurrect it. If we do this, we're going to get this compiler error here. This is the message. You shouldn't really try to resurrect something that is already private to an upstream class. And that's what we are doing here. We are trying to resurrect a member which is private to person, and this is not allowed in C++. If we do that, we're going to get a compiler error. Okay, so, but what I want you to see here is that a public member which was in the base class was also eclipsed down to private level access in engineer. So if we try and resurrect the do something method in our civil engineer class, we're going to get a compiler error. So let's try and do that. We're going to put a public section. Why not?
Oh boy, another public section. Public.
And we're going to go down and say using person. And it say do something. We have this method here. But if we do this, we're going to get a compiler error because this method is now private to the engineer class. And
is it? It should be, right? So we have our do something, and it gets inherited by engineer. So it should be private, but it doesn't seem to be showing up as private. Okay, it is private. So we have our do something const is private within this context, declared private here. Yeah, class, engineer, private person. I like how it goes through every line. It's like, okay, so we ran into an issue when we tried to do this. It's private within this context. Declared private here. And we have our do something const is private within this context, declared private here. Private within this context, declared private here. Interesting that it did it 3 times, or maybe 4. 5? I don't know. It did it a bunch of times. I wonder if that's intentional. Because it seems to be the same 2 lines every time.
Why is it private to engineer? Well, engineer is doing private inheritance. That's going to eclipse
private inheritance seems like a headache.
Private level access by default. So this member is private.
I feel like if you're doing private inheritance, it should probably be like the last downstream.
Engineer, and this is going to be already private to engineer, and we can't resurrect this back. So if you eclipse something using private inheritance, you want to be able to resurrect that to a more relaxed access level in downstream classes. This is the message I am trying to convey here. So this is also going to give us a compiler error. And if we try to build our program, we're going to see that. Let's pass this through GCC. We are going to see that the build finished with errors. And if we go back, we are going to get some kind of error that says that do something is private to some class. It is inaccessible within this context. This is the message we get from this particular compiler we are using. But the bottom line is that you shouldn't really try to resurrect something that is already private to an upstream
private
class.
Inheritance
this
is kind of mad.
Doing here. You shouldn't really do that. Let's comment this out and
he's mentioned that
to compile again.
So he doesn't really like this.
Fine here. This is really all I had to share in this lecture. I hope you found it interesting.
Okay.
We are going to stop here in this one. In the next one, we're going to explore how constructors work with inheritance. Go ahead and finish up here and meet me there.
Oh boy, default ARG constructors with inheritance. Okay. Well, that's interesting. In general, the only type of inheritance you should be doing is simple stuff. Please no more 2000s ass inheritance trees. I have no experience with inheritance of any inheritance trees, but like it seems like the kind of it seems like it can get out of hand really quickly. Like just to use the context of like video games, right? It's like, oh, you have enemy type, and then you have a subtype of enemy, and then a subtype of enemy. And like that's just how you're building all of your fucking enemies, as like inheriting the same fucking, or they're all inheriting each other's shit, which I would be insane. I feel like maybe I'm sure this is possible, but I feel like you can make multiple things inherit from. We did this actually. You can make multiple different things inherit from the same one thing. Like multiple, like I think we did engineer, nurse, and player, all inherited from person. We don't need. You don't need to do like long ass fucking chain where everything's inheriting each other's shit. Not unless you like want it to be a pain in the dick. Yeah, don't do it unless you really know what you're doing. Yeah, that seems to be the key with it, right? All right, let's get this. Let's get this next section. Hopefully, this one is a little bit more. Well, let's see how it goes.
In this lecture, we're going to zoom in at how derived objects are built. And we're going to zoom in on the constructors that we have been ignoring on purpose so far. So here we have the inheritance.
Most languages don't even allow for multiple inheritance because they're so bad. Oh no.
At this point,
they're like,
we
please
have a person
no.
class, which is going to be our base class.
Please
we have
no.
an engineer class, which is now going to be doing public inheritance because we have seen enough of private inheritance. Our engineer class is now going to be nice and say, I am inheriting from person, but I also want my downstream classes to have access to the cool stuff I am getting from person. This is how our engineer class
except
is
for
now.
interface classes. Interface classes are a gift from God.
Which is
oh
going
boy.
to publicly inherit from engineer. But what we want to focus on here is what we get from base classes. So the engineer class is going to have a person part of it, but it is also going to build on top of that and add an engineer level and customize what kind of person it is. So if we inherit from engineer and build our civil engineer class, the first thing to be built by C++ is the person part of this. It is going to build an engineer level of this, and then we are going to add the civil engineer level to add the customizations that the civil engineer class is adding. And C++ is going to do this using constructors. By default, we are going to be using default constructors. If we don't specify a way for the base constructor to be called, C++ is going to call the default constructor to build your base objects. So if we set up something like this and
we know
try
that
to
much
run our
already.
program, we're going to get output like this. We're going to see that the person default constructor is going to be called first. And notice that we are building a civil engineer object. So the default constructor for the most base class is going to be called. Then we're going to be building an engineer layer on top of the person stuff that we get.
There are literally classes that only have methods and no member variables. You will understand why that's OP with polymorphism. Oh boy. Oh, hey. Hey! Fucking cats, god damn it. Oh, what was it? Fuck, I'm blanking on the word. It was not class, it was fucking struct. Isn't that structs? Are you supposed to be down there? I didn't want to get in the way of the video. I wanted to be able to see all the different shits. And I was my fat head was in the way.
Then we're going to build a civil engineer layer on top of the engineer stuff that we have already got. And the compiler is going to do this.
Structs have no methods and only have member variables. Okay, so it's the opposite.
We're going to call the default constructor for person first. We're going to call the default constructor for engineer. And then we're going to call the default constructor for civil engineer to complete the construction of our object. The object will be complete at this point, and we will be able to use it later on in our program here. And hopefully this is going to drive the point home that you should really always provide the default constructors for your classes, because the compiler may call these default constructors in unexpected ways, especially if your class is part of an inheritance hierarchy. For example, if somebody tries to build the civil engineer object and you don't have a default constructor for person, the compiler is going to try and call that, and it's not going to find that, and it is going to throw a compiler error, as we are about to see in a minute. Okay, so the message really in this lecture is that the most base part of your class is going to be built. So for example, for our civil engineer class, we're going to build the person part first, then we're going to build the engineer part, and then we're going to build the civil engineer part of that, and then we're going to finish the construction of our object.
I mean, this sounds like when we were talking about the stack before, right? Where it's like, it'll call, what is it? It'll be the destructor. It'll do what? It'll do person, the derived class, or derived class 1, derived class 2, and then for the destructors, it'll be derived class 2, derived class 1, base class, right? Interfaces have no member variables and only have methods. So classes have both. Structs will only have member variables. Interfaces will only have methods. I mean, I guess that makes sense. Don't get me wrong, interfaces are just classes. Well, I mean, the way that he explained that struct was that they were basically just classes that were private by default, I think. Whereas I think classes are public by default. So it's not too different from what I can understand.
This is the message here. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is default argument constructor with inheritance. We are going to reuse the code from the last lecture because that's going to give us the classes that we need to play with what we want to do in this lecture, and that's playing with default constructors. Let's put
Oh
in our
boy.
starter code, and we're going to open
All
this
of
little
this
guy
code that
in
we've been
Visual
using.
Studio Code. Let's do this.
We haven't
So we're going to have our classes.
we haven't had to change files in like 2 hours with this fucking course. This is great. I get to just keep using the same shit.
We're going to have the main function, which we can play with. And we are going to look at the person class and make sure we have a default constructor. We are not going to default it this time because we want to have a body. We can put our output statements in. So in this case, we're going to go in the CPP file and put in a default constructor. We're going to say person and person and person here. And this is going to be our constructor. We're going to say stdc out default constructor for person called. Okay, so the person class is done. We have a default constructor that works as we want, and we're going to go to our engineer class and we're going to change it to do public inheritance. I think this is going.
Here, let's do like this. And I think that's how we want it, right?
To be engineer class, and we're going to change it to do public inheritance. I think this is going to be much easier to deal with now.
Hopefully, let's go to engineer. We'll change this to public.
And we're going to remove all these resurrection we were doing here from the last lecture because this is no longer going to be needed. And what we really want is to look at our default constructor, which is really in here already. Let's look at the implementation. All we really need to do is put in stdc out and say default constructor for engineer called. And we're going to hop over to the civil engineer class and see if we have a default constructor, and we do have it. And we're going to go to the CPP file and say stdc out default constructor called for civil engineer. So this is going to basically do what we want, and what we really want to see is how, or the order in which our constructors are going to be.
Okay. I don't know why I keep getting rid of that. Oh, well, that time it was actually justified.
Called if we build a civil engineer object. As we have seen here, the person part is going to be built first. So this is going to call the constructor from person. And because we are not doing any kind of customization on which constructor is going to be called, the compiler is going to call the default constructor by default. So we're going to build the person part first, and we're going to see the default constructor for person called. After that, we're going to build the engineer part of us, and this is going to call the default constructor for engineer. And after that, we're going to build the civil engineer part of us, and that's going to call the civil engineer default constructor. This is what we want to see if we build a civil engineer object. So we are going to hop over in the main CPP file and actually build the civil engineer object. We're going to say civil engineer, and we're going to say CE1. We can do that. And we're going to see what happens. Let's try and build this program. We're going to build that with GCC. The build is going to be good. We can run it. Let's bring up...
Oh, hold on. I broke something. Okay. Definition of explicitly defaulted person. What does that mean? It's explicitly defaulted here. So we have our person.h. Oh boy, I'm gonna have to go look. What did we break?
We have a default constructor. We are not going to default it this time because we want to have a body. We can put our output statements in. So in this...
Okay, so that seems to be the issue. Hopefully that solves it. Try to fix it yourself when you break something. I do like to, but I've never seen something like this. Definition of explicitly defaulted person. I assumed that this is what the problem was. Let's see if it's still broken. Yeah. So that seems to be the problem. I must have completely glazed over when he changed that. Because that was... Yeah. So explicitly defaulted. We didn't want this. And the error that I was seeing, I think it was maybe I need to let me see. Definition of explicitly defaulted. Well, that's not the case anymore, I don't think. Full name. By the way, you probably shouldn't be using header guards. Why not? The header guards are like all of this stuff is stuff that I'm doing because I've been told to. Pretty sure the whole thing is just that. Use pragma once. I don't know what that is. Replace the if and def, define and if with a single pragma once at the top. So all this stuff. Oh, whoops. All this stuff can go away if I do pragma. So what is pragma? What does that do? Pragma once. So what is pragma once? What is it? It makes it so your header is only included once, which is header guards, but better, cleaner, and also faster compile times. I assume then that this is supposed to be for the main file then. He didn't teach it, or probably is because it's undefined behavior. Yeah. I mean, there's a lot of things that we just haven't really done a whole lot of stuff with. There's a lot of shit that I'm that I'm certain. Let's see. Yes, finished successfully. Okay. There's a lot of shit that I don't quite understand, but also hasn't been covered. So pragma once in main file, lexical or preprocessor issue. Keep in mind to use but it's been undefined behavior since 1980. Use pragma once on your headers. I guess he didn't explain what linking is and stuff. He explained a bit of what linking was and how the linker, like how when you're using header files it can get confusing because like okay, yeah, if you include it multiple times, like if I include this, right? If I include my engineer header and I have like I include person in my engineer, but if I have multiple things that include person, like if I like when we did the nurse and the other stuff like that, uh, if you're then coming in here and including all of those things that then include person, then you're actually including person a bunch of times, which is different from, or which, from what I understand, is it causes issues with one definition rule because you're like having the same definition multiple times because all the code is being copied and pasted at the top of the page essentially is kind of the way I understood it. So like it can cause issues if you don't do it right. So we have the include guards or the header guards, not include guards. Usually your entire program is actually one huge block of code after linking, but you still need to do forward declarations, but you can't have multiple header definitions, so that's what header guards. Yeah. Yeah. It makes it very difficult, very confusing to try to understand what the hell's going on. That said, this Pragma Once thing does seem this seems useful. Pragma Once are header guards, but you don't have to keep track of defined macros. You don't have long compile times. You don't have to use the awful syntax. C++ tried adding modules, but it became a buggy mess. I assume modules are something that are used by other code languages. From what I've been told, I don't think that headers are a very common thing in modern languages. So but I obviously don't know if that's the case.
In this case, we're going to go in the CPP file and put in a default constructor. We're going to say person and person and person here. And this is going to be our constructor.
No, headers aren't a common thing. Yeah.
Default constructor for person called. Okay, so the person class is done. We have a default constructor that works as we want. And we're going to go to our engineer class and we're going to change it to do public inheritance. I think this is going to be much easier to deal with now. And
all right, so now we have our public
resurrection we were doing here from the last lecture because this is no longer going to be needed.
We did this one.
And what we really want is to look at our
you just say import library and boom, you have library to use. No need to forward declare or whatever. Man, that sounds convenient.
All we really need to do is put in stdc out and say default constructor for engineer called.
Yep, so we have our default for engineer.
I'm going to hop over to the civil engineer class and see if we have a default constructor, and we do have it. And we're going to go to the CPP file and say stdc out default constructor called for civil engineer. So this is going to basically do what we want, and what we really want to see is how or the order in which our constructors are going to be called if we build a civil engineer object. As we have seen here, the person part is going to be built first, so this is going to call the constructor from person. And because we are not doing any kind of customization on which constructor is going to be called, the compiler is going to call the default constructor by default. So we're going to build the person part first, and we're going to see the default constructor for person called.
C++ tried adding import library. It failed and it was a buggy mess. God bless the souls implementing C++ features. That sounds really, really hard.
And after that, we're going to build this.
I can't even imagine being the guy that has to code. It just seems insane. Right now, the best thing we got is fucking CMake. I have no idea what that is. I've never heard of that before.
Civil engineer part of us, and that's going to call the civil engineer default constructor. This is what we want to see if we build a civil engineer object. So we are going to hop over in the main CPP file and actually build the civil engineer object. We're going to say civil engineer, and we're going to say CE1. We can do that. And we're going to see what happens. Let's try and build this program. We're going to build that with GCC. The build is going to be good. We can run it. Let's bring up a PowerShell window we can play with. We want to bring up a PowerShell window we can clear and run Rooster.
Yep,
and you're going
person,
to see
engineer,
that
civil engineer.
For person called, default constructor for engineer called, default constructor for engineer called. This is what we want to see, and hopefully this proves that the compiler is really going to build our civil engineer object in parts. The compiler is going to see that it is a derived object, and it's going to see all the classes that this is deriving from. So it is going to build the most base part first. After that, it is going to build other layers until it reaches the level where we are at this civil engineer objects.
So we used to have to make and build source files, but then make became too cumbersome. So we got CMake to make files for us. What the fuck? That sounds like it's already cumbersome. Like, yeah, like, oh, we're just gonna do this thing, and we'll automate the thing that's supposed to help us do this shit. I don't even, what is a make file even? So we have to use to make. We used to have to have make to make and build source files. So then we got CMake. So you needed to build your own source files before, and then you had something that could just make the source files for you? Oh my god. But it sounds like that was not popular by the sound of it. It sounds like it was kind of a pain in the dick. Kind of a little bit of a pain. A little bit of a struggle, if you will. Okay, but this is acting exactly how we expected it to. And then the destructors, I think, we don't have anything for them, but it would go in the reverse order, if I'm not mistaken. So CMake makes make files, so make files can make projects, but CMake makes different make files, and we end up with different configurations of make files to help us make projects. Make doesn't even feel like a real word anymore.
Again, if we put another statement out here, we're going to say hello in here, and we're going to say stdendl. And I am doing this so that I just have a point where I can put my breakpoint. Some IDEs are not going to like it if you put a breakpoint at an empty line. So that's why I am doing it here. And I am going to try and debug and really show you that we have an engineer and a person part in us. I have shown you this before, but it doesn't really hurt to repeat this because debugging is really cool. It's going to give you more information than you could ever ask for. We're going to hit our breakpoint here, and if we look in our locals, we're going to have our civil engineer object, which is
Source files are your .cpp files, it's source code. I mean, that makes sense. It's different from the header files, I assume. No more English obfuscation. Instead of manually compiling it with a G++ command, we use a make script to automate that process for us. Oh my gosh. Wait, you needed to... Oh. So G++ and like compilers and stuff like that were not, I mean, like, I guess the compiler would have already existed, but you needed to like actually type a thing? Or what? You still need to? It's better to use a make script than to manually compile it with a terminal. Is it? Is it just more efficient? Faster compile time? Think about it, there are different types of compiling. I mean, yeah, I know that we've used to make before I even started this fucking started streaming this course, I needed to configure I think it was 3 different compilers for this fucking thing. Like we had G++, MSVC, which is the default one from what I understand, and Clang or Clang. I don't know. I still don't know which one's correct. Compilers can have debug modes, release modes, optimization modes, and non-optimization modes. Yeah, so when we use a debugger, at least for this project, what we've been doing is like we're using the debug mode of G++ or GCC, I think is what it's called. I keep calling it G++ because that's the thing that I see. That's what I keep looking at when I look at the names. Instead of manually writing out the flags, you just go use a simple make script. Huh. And how simple is a make script? But it got too hard for different to use for different platforms and such. We just use CMake to automate make files for us. Okay. So it's like a more efficient, I guess, fuck, not. It's more efficient than just doing like one of these deals. Is kind of the assumption. It's pretty simple, assuming you already learned C++. Well, that is a from what I've seen, people seem to be kind of baffled by C++. So already knowing wizardry, it's like, well, yeah, of course you can do that. That's not too hard. I can cast a firebolt. That's easy.
Is in scope now, and you see that we have an engineer part of us, and the engineer has a person part in it. So what the compiler is really going to do when it is building a civil engineer object, it is going to build the most base part of us. So it is going to build the person part.
CMake is your arch nemesis. Oh no.
An engineer layer on top of that, and then it is going to build the civil engineer layer. And that's what we see in our output when we get to run our program.
You are now a fucking wizard. You are the god of programmers. What? What do you mean? Ah! I can't cast. My casting is weak. I have not an orb upon which I can ponder.
When we to build the civil engineer layer, and that's what we see in our output when we get to run our program here. If we go back, we're going to see that we still have our binary. We can still run it. Let's bring up a terminal window we can use to run this. We're going to run Rooster, and we're going to see the order in which our constructors are called. And this is really cool. Now that we have just debugged this program, we can take out this hello line because it's really useless. And this is really what I wanted you to see. Constructors are going to be called in your inheritance hierarchy, starting from the most basic, going down to the most specialized.
I cast void. Oh no. Oh no. Not the lambda function, not like this. Not the anonymous function call. No. Oh god, that shit was so fucking weird when I was looking at it. I still don't like I understand the concept of them, but I don't know if I'd ever be able to use them in anything but the most basic of settings.
And we're going to keep going until we reach the most specialized, which is civil engineer here, to build our object. And our object is really going to be built up in layers. This is the message I am trying to convey here. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see that we can actually actively call a base class constructor from our derived class, and that's going to add much more flexibility in how our objects are built. We are not going to call the default constructor. We're going to be calling our own constructors and have much more control on how our derived objects are set up and built. Okay. Go ahead and finish up here and meet me in the next lecture.
Well, that was not what you normally say. Go ahead and finish up here and meet me there. All right, let me see. What is it not like here? Definition of explicitly default value constructor. I don't think that's a problem anymore. I don't know why it still says that. Pragma in main file. Lexical or preprocessor issue, but it doesn't actually stop me from compiling, so I don't think it's a problem. Not really.
In this lecture, we're going to see a
All right,
way we can
lecture.
instruct
Let's go.
for custom constructors to be called when our derived objects are being built and set up. In the last lecture, we saw a figure like this. We had an inheritance hierarchy that went from person to engineer and to civil engineer. And we saw that if we set up a civil engineer object, a person part is going to be built first, an engineer part is going to be built on top of that, and the civil engineer part of that is going to be built.
Right. This all makes perfect sense. We've covered this a few times now.
Civil engineer object. But in the last lecture, we saw that this was calling the default constructors, and sometimes you don't want this. You want your objects built in a specific way, for example, through a bunch of parameters that you pass to your constructor. What if you want this kind of setup? This is what we are going to learn about in this lecture. And what we want to end up with is something like this.
You know, so this is actually something I've been kind of curious about for this whole time. So, like, oh, maybe he's doing it here. Okay, so he's creating a person. So he has Jon Snow, Winterfell Cold, and the address. And so he's got the name, age, and address. So then he has the engineer. He has the name, age, address, and then I think that's the number of fucking, what are they called? If I'm not mistaken, this is the number of contracts. Let me see. Yeah, contract count. Which I don't think we actually have anything but the default constructor for our derived classes. So I wonder if he has to do... I'm curious how we do this in the header file. But then the civil engineer has the name, age, address, contracts, and then what is the civil engineer one? Let me look at the header file real quick. Specialty. So his specialty is road strength. I'm curious whether this is something that we just do it like... Alright, I'm just gonna watch the video. Instead of speculating, I'm gonna watch the fucking tutorial that I'm watching.
We will be able to build a person object by passing in a bunch of parameters. We can pass in the full name. We can
Why is he talking about John Travolta?
This is the age.
I mean, we've got Daniel Gray, Jon Snow, and John Travolta.
An engineer object by passing in this kind of information. We can pass in the name, the age, and the address. But we can also pass in the contract count. I think this is the new member variable we had in our engineer class.
It was.
But we're not going to stop there. We can also build a civil engineer object, and we can pass in the information. Again, a civil engineer is also a person. So we're going to be passing the information that is going to initialize the person part, and that happens to be the name, the age, and the address. But a civil engineer is also an engineer, so we're going to pass information that portrays to the level of an engineer, and that's going to be the contract count. And we're going to pass the information to initialize the civil engineer part of this object, and that's going to be the road strength. And hopefully from this you can see that we need a way to forward all this information to the constructor where this information is needed. For example, if we are building a civil engineer object, we want to forward the name, the age, and the address to the person part of us. So we need to pass this to our person constructor in a way. We need to pass the 31 here to our engineer constructor, because this information is going to be stored at our engineer level, and we need to store the road strength information into the civil engineer part of us, because that's where this member variable is declared. Hopefully you can see the need to call custom constructors which are not default. These custom constructors are going to allow us to forward information when building our objects, like we are doing here in the main function. So let's see how we can do this. Some of you might think, if I am building an engineer object, I can just grab the information and pass that to my base class. And that is simple, right? So we can grab all this information. We can grab the full name, the age, and the address, and pass that to our base class using the syntaxes we have here. If we are doing public inheritance, we're going to have access to these guys anyway. So we can say full name equals full name, age equals age, and say address equals address.
But that one doesn't work.
For the address is actually private to the person class, and we can't do something like this.
We're not able to do the person scope thing, right?
From the base class and modify it.
Because that's private.
We're going to get a compiler error
still
that
private,
says that the address is actually private to the base person class. We can't do this, so this is not going to work. Okay, some of you might think, what if I try to use an initializer list and do something like this? So I can say m full name and pass in my information. I can say m age and put in my information. I can say m address and put in my information, and then initialize the member variable that actually belongs to the engineer class that we are trying to build an object for here. And hopefully this is going to work, except the compiler is not also going to accept this. The reason is, with initializer lists, you can't initialize a member variable that doesn't belong to the class that you are trying to build an object for. So for example, here we are trying to initialize m full name, m age, and m address, but these member variables don't belong to the engineer class.
They belong
that
to the
we
person
are trying
class.
to build an object for. So we're going to get a compiler error here. This is not going to work. It is not engineer's job to build or set up these member variables. So this is not going to work. Okay.
This is actually something that I've been curious about while we've been doing this, because I've looked at while I've been looking at like the engineer class and shit like that, I see that it's like, oh yeah, we have a private member variable for civil engineer, a private member variable for engineer, and then three different variables, one of which is private for person, and one's protected and one's public. So if I wanted to create a civil engineer class, how the hell do I use the private one? Like if everything is public, it's I mean I think I think you said it was like the first one should be fine. Like it will work. But I think you said that it was not ideal. This one is kind of also not correct because we still can't access address, I'm pretty sure is the problem again. Well, yeah, we still can't do it. I don't know if we're able to do full name or age as well, because he was saying that it doesn't belong to engineer, but it's inheriting publicly now, so I'm not 100% on that, but yeah.
Okay, so how are we supposed to forward information from derived classes to base classes? Not to worry here. We can still use initializer lists, but we are going to use constructors whose job is going to be to initialize these member variables. So if we are building an engineer object and we have information that really belongs to the person part of us, we're going to call the person constructor to actually use this information to build the person part of us. And we're going to be calling the person constructor in our initializer list here. And after we do that, we're going to initialize a member variable that actually belongs to us in our initializer list. And this is going to forward information from derived classes. In this case, the engineer is the derived class, and the information is going to be forwarded to the person constructor, which is our base class. This is how this is going to work. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Here we are in our working folder. The current project is constructors with inheritance. We are going to grab the code from the last lecture because that's going to be our starting point, and we're going to paste this in our current project. We are going to open this little guy in Visual Studio Code by dragging and dropping here, and this is going to give us our starter code. We're going to have a person class, an engineer class, and a civil engineer class. And this is basically going to set up the hierarchy we have here.
So
And what we want to achieve
we're going
is
to
to be able
need to
to call
create
our
2
own
more
custom constructors
constructors, I
when we
think.
build our object in layers. Information is going to be coming from a civil engineer object, and we are going to initialize the person part of us with relevant information. We're going to initialize the engineer part of us with relevant information, and we're going to initialize the civil engineer part of us with relevant information. This is what we want to achieve. Okay, for that to work.
So if I'm not mistaken, we have our custom constructor for person, right? So what we're gonna need to do, because here we have our string view full name and our string address, or string address. The address for this stuff we don't know yet. But so we have our custom constructor for person, so we can make a person if however we want at this point. Engineer and civil engineer are both only have default constructors, so we're going to have to I'm pretty sure what we're doing is creating custom constructors for these two. Fuck, if I could remember what it looked like, I think it would be. Oh, it was. Ah, ah. I like want to try writing it and seeing if I can do it right. All right, let's try. Let's just give it a shot. So this is our. What am I doing? Why did I do that? We need to go to this thing. This is the one I was looking for. I don't know why I copied the other one. So basically, let's just check with engineer real quick. So we're gonna change this real quick to engineer. And then I think it was like this. Oh no, I don't remember. It was something like this, and then we did and then it was we just had it as contract count. Int contract count. Yeah, expected an identifier. And then this is something else. What is this? Expected to close parentheses. I don't remember what it looks like. Fuck.
We need to not call default constructors. We want to call actual constructors that are going to grab the information and forward that in our member variables. For example, in person, we have a constructor which is going to take 3 pieces of information, and it is going to pass this information into our member variables.
Yep.
We need to apply a few changes here. For example, our third parameter is passed as a const string member type. We are going to change this to be std string view because this is going to save us on copies. Let's say string view here. This is going to work. And this is going to forward information in a way we want. We're going to change our third parameter to be std string view. Let's say string view here. We're going to say std string view. This is what we have in our header. We're going to be having the same signature for our function here. And what is wrong? We have m full name, mh, and we have m address here. Let's try to build and see if the error goes away. Sometimes Visual Studio Code is playing games on us. If we get a compiler error, we're going to try and fix that.
Okay, so his is not. His is fine. I'm pretty sure this is all fucked up and wrong. I don't remember I don't know what it actually is supposed to look like. So we have string view, and then we have string view, string view. Let's try. Make sure I didn't break anything. Okay, didn't break anything. Good.
that you see that it is Visual Studio Code playing with us. The code is just fine here. So we have our constructor for person. It is going to forward information using our initializer list here. We're going to look at our engineer class. If we go there, we're going to see that we don't have any constructor, which is going to grab information in any meaningful way and put that in our class. So we are going to put in a constructor that looks like the one we have in our person class. So we can just grab this. I like copy and pasting because that's going to save me a few seconds. So I am going to put my constructor here, only it is not going to be called person, it is going to be engineer.
Okay, so I was right
and
about
I am
that.
going to add a contract count member. And this is
so we have our string view full name, int age. For some reason this is const, which I don't think it needs to be. And he copied this, so I'm going to go ahead and get rid of it from this one as well. And these don't need to be const by the looks of it. So we have our const, or our just std string view full name, int age, std string view address. Okay, and then we have our int contract count. So this one I think is still going to cause a problem for reasons I don't, because this thing is supposed to be private to person. So I think that we have to do something else with that. I don't remember what the thing looked like when we saw it briefly in the lecture.
This is going to be an integer here to keep things simpler. And we are going to put an implementation of this constructor in our engineer class. We can go down here and put that in front of other constructors. Let's look at the order we have in our header because I like to be consistent. The default constructor is first, so this constructor is going to be second. And we're going to say that it belongs to the engineer class using a scope of resolution operator here, and we are going to put in our initializer list. Now, what we want.
Okay, so we have this is our implementation. Engineer in the scope of engineer. So we have our string view. What is this? May not be redeclared outside its class. I'm going to trust the process real quick. So we do this. So this is string view full name, int age, string view address, and our contract count.
What we want to do is to call the constructor for person to initialize a person part of us, and then we're going to grab the information for the contract count and we're going to forward that in our own member variable. The way we're going to achieve this, we're going to call the person constructor and we're going to pass in the full name, we're going to pass the age, and we're going to pass the address. And then we're going to initialize our own member variable, which is contract count, I think. Let's go to the header and look at that. We're going to see that our member variable is contract count. So we're going to say contract count, and we're going to say contract count param. We're going to name this differently because we don't want issues with naming here. So let's name our parameter here param. This is going to not confuse the compiler. And once we have this n, we can just put in the body, which is going to be empty because all the initialization is now done in our initializer list here. So if we...
Okay, so we have that. And then we do boom. So this is the constructor. Alright, so this is, okay, so I know why we do this now. It's so that we can put shit in here when we default use a custom constructor, or for other if we want something else. Okay, so reading this, we have when we create an engineer, we will put in our full name, age, the string view address, and then our contract count parameter. So it'll be it'll be string int string int. And from what I understand, when we do this, we are using the person constructor for the first 3 variables, and then the contract count, and then we're using the contract count. We're filling in, Jesus, I need to talk properly. Our contract count parameter is going to be equal to, will replace contract count as the member variable in our header. Let me make sure that I haven't broken anything yet. Okay, so it's still not broken. We're good.
If we do this, we're going to see that the compiler is going to be happy with our thing here. We're going to go down in our civil engineer class, and we're going to grab the constructor we have in engineer because we're going to be using this as a starting point. We're going to copy it and go in our civil engineer class. We're going to see that we don't have a customer constructor. We're going to put this in. We're going to name this.
So with this one, so hold on real quick. I'm going to copy this whole thing. I want to see if I can do the civil engineer one without before the tutorial finishes it. So here we have our civil engineer and civil engineer. To take a string view full name, our integer for age, our std string view address, our contract count parameter, and we also are going to do, I think it's another integer. No, it's another string view. So here we do std string view, and we're calling it m specialty, I think. Specialty. This one, so if I'm not mistaken, the way this works, what is this? Indirect non-virtual base class is not allowed. Qualified name is not allowed in member declaration. Hold on. I think that this goes. It was. If I just do engineer. I don't know if this will be. This doesn't feel right. This feels like it'd be really awkward if it works. No. Yeah, this doesn't work. We have our civil engineer. I haven't misspelled it. I think this first part is actually correct. This part is definitely wrong. I'm gonna put this down for a couple lines. So we have our string view. I think the thing that's getting me messed up is if we do it like this. Here, what if I do it like this? Person engineer indirect non-virtual base class is not allowed. Yeah, because this next one would just be the if I look at the engineer class again. Wait, what? Did I change something? I feel like I changed something from this. Did I not have the person thing in here before? That's in the implementation. Okay, hold on. Hold on. I'm fucking myself up. Alright, we're gonna get rid of this whole custom constructor real quick. We're gonna go to our engineer constructor. Copy this. Go to the civil engineer header. We have this, and we're going to do std string view, and what did we call it? M specialty. We're gonna go ahead and I'm just gonna do this for readability so that we can see that this whole deal. I do like this. This whole thing is the constructor, our custom constructor. So this should be civil engineer. So this looks like the thing should be working, right? Because if we look at our engineer, we have our string view full name, int age, string view address, int contract count, and then here we have our string view full name, integer age, string view address, integer contract count, string view m specialty. Our contract count. And then when we go to our implementation, we will take this. We'll take this implementation. Take this, copy it into this one. So that's the default constructor. This is our custom constructor. And we're going to do our full name, age, string view address, integer contract count parameter, and then we do our fucking. I'm gonna have to rename that. You know what? I'm gonna just do it now. Civil engineer, and then this one is also adding std string view m specialty. That is what it was called, right? Specialty, yes. Okay. And then this one, so what is this? Indirect non-virtual base class not allowed. So this one I still don't know if this is going to be correct. This one though, this one might be, because this is our implementation. God damn it, fucking trying to click shit. So it's not giving us any problems with engineer, but it is giving us problems with person. Full name, age, address, contract count param. And then if I look at the engineer implementation, contract count is contract count param. So then we do this one is we're going to call it M specialty param as well, I think. Parm. So this This is giving me an error with this one, where it's telling me indirect non-virtual base class is not allowed. So I'm not sure if that means I don't need this because the engineer class is going to cover it, or if I have some other thing that I need to do for it that I just don't quite understand yet. So this is my guess. All right, let's take a quick look. This is my guess as to the implementation of the civil engineer constructor. And this, I mean, this is for readability, but specialty. This is my guess for the the custom constructor for it. I'm not confident in this. This is kind of me trying to logic it out. So let's see if let's see how close I am.
Civil engineer, and we're going to add a specialty member that we want to initialize. So we're going to say std string view because we want to forward string data. We're going to say std string view here, and we're going to say specialty, and we are going to put the implementation of this in our CPP file for civil engineer. We're going to put this below our default constructor. Let's grab this. I lost this somehow, so we're going to copy and we're going to paste down here. We're going to say that this constructor belongs to the civil engineer class. We're going to use our scope resolution operator. And after this, we're going to put our initializer list. In civil engineer, we will call our engineer constructor.
Okay, hold on. So do I have to do it the other way then? So we have our specialty param. I'm going to do this thing like so.
And it is going to be taking 4 things. We're going to pass in the full name. We're going to pass in the age. We're going to pass in the address. And we're going to pass in the contract count, which we will get from our constructor from civil engineer, but we will also initialize our specialty member variable. So we're going to say
okay. So the person thing seems like it's unnecessary
specialty,
right now.
and we're going to pass the specialty information here. And this is going to initialize our thing. We're going to put in an empty body, and our information is going to be properly forwarded to our base classes. So if we build the civil...
Oh, yeah, you don't need this one because engineer already has it. So if engineer already has it, it will do this portion, right, when you do the engineer constructor. So we just do engineer. Oh, whoops, that's the wrong one. We just do engineer. That calls the required oh god, what did I fucking call this thing? M specialty param. Actually, we need a contract count param. And then this one is just M specialty param. Which I think that's kind of what's happened here is he's got just calling it specialty and having that fill the M specialty thing, but I'm calling it a parameter. So this should be correct if I'm not mistaken. Let me see. Because we have our string view, full name, int age, string view address, contract count, string view specialty parameter. So we put these things in, and we call our engineer constructor, which when we do that, will in turn call our person constructor for these things. So it will forward the information from this to the person stuff, this to the engineer stuff, and then this will of course be our civil engineer parameter. Okay, that makes so much more sense now. Oh, I don't know why I didn't think of that. I was trying to like call them separately for some fucking reason. It makes no sense to do that in retrospect. God damn it. Some of the things like you ever think about like how strategy is one of those things where like if you're sitting there in the moment, you're like it's really difficult and murky to see the way forward, but then like you see the correct path and you're like, "Oh, well, duh. Just do the obvious thing." And it's kind of like that's kind of the feeling I'm getting now. It's like a lot of this feels like, "Oh, duh, just do the obvious thing."
Engineer object, proper information is going to be forwarded to the engineer part of us. And proper information is going to be forwarded to the person part of us. Now that we have this in place, we can put in our stdc out statements to let us know which constructor was actually called to build our thing. We're going to say that it was our custom constructor that was called, or let's say that here. We're going to say custom constructor called for civil engineer. We are going
Here, let's copy that thing. We have this one. Copy that, but then we're going to change the word to uh, custom constructor for engineer called. We're going to do like this. Copy that. Go to this one. Do custom constructor for civil engineer called. And then this one has custom constructor for person called. So the way, if I'm not mistaken, the way that this will work out when we go back to our main, we should be able to do civil engineer. If we do civil engineer C1 like this, it will just call our default constructor, and it'll create essentially an empty object with no unique information that we have entered into it. But what we should be able to do, if I do like this, civil engineer CE2, and we're going to call him Biggs, where was it? It's Biggs McGee. What was it? It's, what are our member variables for person? We have it's our full name, our age, and then our address. So we have Biggs McGee, who is 32 and lives on fucking, I don't even remember the numbers. Negra Arroyo Lane. I don't even remember. All right. He is a civil engineer who has, call it 25 contracts, and his specialty is fucking oh, call it, what was it? Overpass angles. I don't know. Overpass slope, we'll call it. So this, if I'm lucky, if I've done this correctly, if my understanding is correct, this should call first. We should see our civil engineer, or it'll say person default constructor, person or engineer default constructor, civil engineer default constructor, and then we should see our civil engineer. It'll be person custom constructor, civil engineer custom constructor, and civil engineer custom constructor. I don't think we actually have any of this stuff printing out, any of this information as of yet. let me see if I can build this. Please tell me I didn't break something. Please tell me I didn't break something. I broke something. Fuck, what did I break? Finished with error. So if we're looking at this, in function int main. Oh, is it just that I didn't? Ooh, I didn't break something nearly as badly as I thought I would. Holy shit. Okay, so terminal. Okay. Oh shit. Oh shit. Okay. Moment of truth. Did I fuck it? Did I fuck it? It should call. It should give us 6 lines of text, I think. 3 default constructor, person, engineer, civil engineer, and then 3 custom constructor. Fucking person again, person, engineer, civil engineer. Yes! Holy shit! Fuck yes, dude! Holy! That is so fucking cool. And this should have our information correct in it. Okay, I need to find out where's my implementation to print this shit out. I want to print the information out. He's probably going to do that
Going to
next. Let's
go
see.
to our engineer class and also say the same
Fuck yes,
thing.
dude. That is
Let's go
so
to the
cool.
CPP file for that, and we're going to put in our stdc out statement, and we're going to say custom constructor. We can copy this to be consistent with what we had in our constructor,
dude,
default constructor, I should say.
I'm
And we're
still.
going to say custom constructor called for our engineer class. We're going to go back to person, and we're going to go to the implementation file, and we're going to copy the message from our default constructor, and we're going to put this in and say that the custom constructor was called for person here. So now that we have these guys in, we can go to our main CPP file and include the classes. They are included here. We can try to create a person object just like we saw in the slides.
So we have our Jon Snow, 27,
and
Winterfell.
build this program and see which constructor is called to set up this person object.
So we know that we did it correctly because
by now we know that our custom constructor
it called the correct constructors. So that makes me happy.
Passing 3 parameters which should be forwarded to our member variables through this initialize list. So let's build with GCC and make sure this is what we expect. We're going to use our compiler here. The build is going to be good as you see here, and if we bring up our PowerShell window and run Rooster, we're going to see that our custom constructor is called. Let's bring up.
Okay, so he has something for printing it out, which I don't think I did for myself. So let me. Oh yeah, why the fuck didn't I just do that? It's the person one. So we'll do. So he's printing out a person right now. I want to print out the whole civil engineer. So let's do our thing. So stdc out, and we're doing It was CE2, and we're gonna just do like so. It should just be CE2 std end line. Let me make sure. Let me look at the civil engineer because this should have our stuff. Yeah, so this whole thing should print out all of our information for him. So this, I'm gonna go here. We're gonna get rid of the first civil engineer because we know that it'll call the default constructor and that it works. Actually, no. Let's not do that. What we're gonna do, I'm gonna do like this, and we're gonna print out both of these. So let's do CE1. So this one should just have our default information, which should be pretty empty, pretty bare bones. But these are 2 separate objects. So let's run task. Build, okay. So it'll call the constructors. I think it calls them both. It should definitely do the 6 lines again like this. And then it should print out our information. First, it should be something that has like basically no information except whatever we start initializing. Like I think person, what is our default information? So full name is none, age 0, private none. So our it should be none 0 none, and then our engineer default should be 0, and our civil engineer should be none. So it should be basically just nuns and zeros. The other one should be the information that I've put in here. So it should be Biggs McGee 32, Negro Arroyo Lane 25, and Overpass Slope. So let's give this a shot. Constructors called as expected. We did that one already. Full name, none. Age, 0. Address, none. Contract count, 0. Specialty, none. Full name, Biggs McGee. Age, 32. Address, Negro Arroyo Lane. Contract count, 25. Specialty, Overpass Slope. Dude, it's fucking good! Oh, now the difficulty will become with doing something like this on my own.
The main CPP file so that we can see our thing. We are passing this information here and we are printing our person object.
Dude.
And we're going to see that the full name is Jon Snow, the age is
polymorphism.
27, and the address
Wait, if
is
person is a
Winterfell,
class is inside an engineer class, does that mean we can use a person class to refer to engineer classes?
Okay, so this is
working.
No. We can also set up an engineer object
and see
that the information is being properly propagated to the person part of our engineer object, because engineer is
it's all polymorphism all the way down.
We are passing the information for the full name, the age, the address, but we are also passing in the contract count, which should be used to initialize the engineer part of us. So we are going to run the test to build with GCC. The build is going to go through successfully, and we can bring up our PowerShell window and run the program again. We're going to see that we're going to print the information for person, custom constructor for person called. But what we really are interested in here is seeing that the custom constructor for person is called for building our engineer object, and then we call the engineer constructor. And again, this falls in line with what we saw in the last lecture. The most base constructor is called first, and then the most specialized constructor is called last. In this case, we are just setting up things in such a way that our custom constructors are called, and we do that from our engineer class by calling the base constructor explicitly using the syntax that we have here in our initializer list. After we have the base constructor called, we are going to initialize our own member variables, and that's what we see. And in this way, the information for the current class will be initialized properly, and this is what we see here. I think this is a little bit misleading because we still have the information from the person object that we built printed out here. We can comment this out and build again. We're going to pass this through GCC to build our program. The build is going to be good. We can clear and run rooster, and we're going to see that the custom constructor is called for person to set up the person part of us, and then another layer of engineer is going to be set up in our object to initialize the contract count member variable part of us, and we're going to have the information here. So if we print the full name, we're going to get Daniel Gray, the age is going to be 41, the address is going to be the gibberish we expect here, and the contract count is going to be passed in successfully, and this is really cool. We can also...
I'm just so glad that it kind of clicks what I'm doing now, what I like understanding how this works. This feels like it's really... I feel like the hardest part of this, of all this code, right? So far, is trying to set things up so that they derive in a way that makes sense. So that because like right now we have our person implementation and our person header, getting all of this stuff set up, right, and ready to like building the constructor. Building, what was it? It's like 3 different constructors that are all custom, that are like, that require slightly different things. Like with this one, I'm still embarrassed that I didn't immediately think to just do engineer, because of course engineer inherits the person one as well. So to do this shit with, like that makes perfect sense in retrospect. But getting all of this set up and trying to logic this out and make sure all of this works and makes sense, I think this is the part that is most difficult about this whole uh process, I think. Because once this is up and working, now I can go in here and this is really easy. Just making objects and, like, for whatever using them for whatever purpose it is. It seems like that's like that part is pretty easy by comparison to, like, actually building the fucking things. And, like, and I imagine that this can get, like, the use of the objects can be pretty intricate as well, but, like, you still have to, like, put those building blocks together and make a bunch of objects. Like, I mean, in this case, we can hypothetically make three different kinds of objects. They're derived from each other, but we still have to make them individually. I don't I don't know if this was clicking for me before with, like, the implementation portion, but now as I'm, like, looking at it, it's like, fucking what's wrong with me? Of course it makes sense.
I'll comment this out and set up a civil engineer object. We can do that. Okay, so let's go down and put this in place. We're going to create a civil engineer object. We can close up
We're gonna
the
try
left
something
sidebar here to have some more breathing room. We're going to build a civil engineer object. We're going to pass in full name, age, address, contract
Let's just make
count,
a regular
and
engineer.
a specialty, which I think we expect from our civil engineer custom constructor here. That's going to be an STD string. That's what we are passing in here. I should say that's going to be a string view, but we can pass in string data just like this, and the string view is going to take it. So what we're going to see here, we're going to see the person constructor called, the person custom constructor, I should say. We're going to see the engineer custom constructor called, and after that, we're going to see the civil engineer custom constructor called to pass and forward all this information in related parts of our civil engineer object. Let's build and see that this is actually going to even compile.
Honey, I'm home. Did you have a hard day? Want me to pour you a cola? No, by the way, rub my feet. Give me something to eat. Fix me up my favorite treat. Honey, my back is killing me. I need to relax and watch TV. Get off the phone. Give the dog a bone. Hey, 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 hey. Honey, I'm home. And then we can do this, and we'll just print out ng1, std and line, and we'll do the same for, we might as well keep the ce2 as well. I'm hard every day, are you? Are you now? No, this thing. So this should, let's actually just make a person as well. We'll call this one, we'll call this one lazy. It'll be lazy. Lazy. And I think that the number, I'm just gonna 0 0. Yeah, call it 0 0. And address will be what is the name of that Discord server? We the squad. There we go. And then I'll print out lazy. std cout, and we'll do lazy. Lazy. std and line. Boom. Boom. You're getting good at this programming thing, man. That is a bold-faced lie. This is capitalized. I mean, I like to think I'm understanding some of these concepts. I don't think I will actually consider myself good at this stuff until I've, like, set my mind to some kind of thing where I've done it, like, I've built it myself. I think until I do that, I will probably be in denial about understanding any of this shit. Alright, so let's clear all of this. So this should call... Let's first build this. It should be fine. I'm doing something kind of similar to what he's doing. So what this should do is first it'll call 3 constructors for person, engineer, and civil engineer. Then it should call person and engineer. Then it should just call person. Fucking constructors. I've fed the requisite... They should all be custom constructors. They should print out... This one we know works... Or no. This one we know works. We actually do these in the order that makes sense. Because it's going to be from most to least. Most specialized to least specialized. So we do that. Let's terminal run task. Should be fine. Boom. And then we can run this. So it'll give us 6 constructor messages again. And then it will print out all of the information for each of these dudes in regards to what we've done. So, boom. So we have person, engineer, civil engineer, person, engineer, and then person. So our civil engineer, CE2, Biggs McGee, age 32, address Negro Arroyo Lane, 25 contracts, overpass slope is a specialty. Then we have our engineer, NG1 is a Billiam, his age is 19, his address is Warpwood Way, his contract count is 12, and then we have a person called Lazy, who his full name is Lazy, his age is 0, address is We the Squad. Fucking... Dude, this is good. This is good. I'm hyped about this. I feel good. I feel good. Na, 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 na.
The build is going to be good. We can clear and run Rooster, and we're going to see that this is exactly what we expect.
Yep.
The custom constructor
Damn right it
is
is.
going to be called after
because we did it correctly. That's why it's doing what we expect.
Engineer is going to be called, and then the custom constructor for a civil engineer is going to be called. And this really falls in line with what we expect if we are building a civil engineer object. And the civil engineer class happens to be inheriting both from engineer and from person. We're going to have the person part of us built first. And because of this, we're going to see the person constructor called. But in this lecture, the real focus is getting our custom constructor called. So the person custom constructor is going to be called. After that, we're going to call the custom constructor for the engineer part of us. And that's going to set up the engineer specific member variables in our object. After that, we're going to set up another layer of civil engineer in our object. And this is going to initialize the member variable that belong to the civil engineer part of us in our object. So this is really the main goal in this lecture, showing you that you can set up things in such a way that your custom constructors are called when setting up your object in layers as you see here. Okay, now that we have this working, I want you to see that there are some bad ways to do these things, and some people are actually going to try to set things up in that way.
Let's try not to do bad things.
The first bad way is to try and initialize our member variables
he talked about this before.
body of the class. If you do things like this again, this is going to work because full name and age are going to be inherited publicly from the person class, so the code here is going to work. But we have no way to initialize the address member variable because it is private to the person class. So if we try to access that, we're going to get a compiler error. Let's try this out in code and see the actual compiler error. To try
it should just say private in this context or something, right?
Good code here.
I'm not going to
copy.
I don't want to edit my code to break
that
it.
is going to be problematic.
I don't want to do
as
that.
we saw in the slides. I am going to paste in my constructor here. I should close my PowerShell window here. And I am going to take out my initializer list because we're not going to be using that here. And we're going to just grab the data and use that to initialize our data in our member variable here. So we're going to grab the full name and say mFullName equals full name. We can do that. We're going to say mAge equals age. That's the information we get. We're going to say maddress, and you see that we don't even have that in autocomplete. So we're going to pass the address. We're going to be stubborn and ignore these squiggly lines. And we're going to say speciality, and we're going to grab the speciality and pass that in. But you see that line 26 has a bunch of squiggly lines. And the reason is the maddress member variable is invisible and not manipulable from our civil engineer class. Again, the reason is that the address member variable is private to the person class. So the civil engineer class has no business initializing this in the body. This is not going to work. So if we try and build this, we're going to pass this through GCC. We are going to see that the build is going to finish with errors. And if we go up, we're going to probably see the error.
Private within this context. What did I say?
Within this context. And
did I say private within this context? I think I did.
That in the civil engineer CPP file.
Inaccessible within this context, whatever it is.
This is what we see here. And this is the offending line. We shouldn't really be doing this. If we comment out this line, this is going to work, but our member variable is going to be left with a junk value. And this is really not good because our address that we worked so hard to set up in our parameter here is just going to be ignored. So this is bad. You shouldn't really be initializing
you don't want to
your member variables.
You don't want to waste your own
especially
effort.
If you have an inheritance hierarchy in your classes. So we're going to comment this out and say that this is really bad. It's going to give you compiler errors. And some of you are going to say, okay, this is not working, but what if we try to use an initializer list directly? Let's see if that actually works. We are going to set up another constructor here, and we are going to set up the data in our initializer list. We're going to say, let's say mFullName, and pass in the full name. We can do that. Let's try this out. We're going to say mAge, and we're going to pass age. We can do that.
It's already given them squiggly lines. That's not good.
And we're going to pass in
I hate engineers CPP files.
And after that,
that's
we're
just
going
me.
to say speciality, and we're going to pass in our speciality information.
Whoa, lazy. Whoa.
But you're going to see that we have squiggly lines here. And the problem with this way of doing things is that the civil engineer class has no business initializing things that belong to the person class in the initializer list. Your initializer list only has the capability to initialize the member variables that belong to the current class. And mFullName, mAge, and maddress don't belong to the civil engineer class. That's why we're going to have a compiler error if we try to set up things in this way. If we're trying to build the program, we're going to get a weird compiler error. We're going to see that the build is going to finish with errors, and it is going to say expected initializer before mFullName. And we need a colon here. Sorry for this. So this is not the error we expect, but you see that the moment we do this, we have a bunch of squiggly lines on full name, age, and address. And let's build and see the problem we have. And we're going to build with errors as we see here. If we go up, we are going to see our errors. Civil engineer does not have any field called mFullName. We're going to see that civil engineer doesn't have any field called mAge, and civil engineer doesn't have any field named mFullName or maddress here. That's the problem. We have no business initializing these member variables that don't belong to the civil engineer class in the first place. So this is also not going to work. The best bet we have really is to call the base constructor and let that initialize the member variables that belong to our upstream class in the inheritance hierarchy. For example, in our civil engineer constructor here, we need to call the engineer constructor to initialize the engineer part of us. And we're going to be forwarding the information, the full name, the age, the address, and the contract count. The engineer class is in turn going to call its base constructor to forward the information about the full name, the age, and the address. And it is going to initialize its own member variable, mContractCount, and the information is going to be passed in correctly. And if we try to build our class now, we're going to see that everything is going to work. And I really wanted you to be aware of this, because the moment you understand this, you're going to set up your inheritance hierarchies in a way that is going to make sense, and you're not going to be getting all these weird compiler errors. This is really all we set out to do in this lecture, showing you how you can set up your own custom constructors in your own inheritance hierarchy. And at the moment you do that, you're going to get your classes called in the order that you expect. Things are going to be set up in layers. The base constructors are going to be called in a way that you expect, and your objects are going to be built in a way that you can print them and see the information that you expect set up in your object. If you want, you can also use a debugger to see the information in your thing. So we're going to set up a breakpoint here, and we're going to bring up our debugging tab.
Oh boy. Bringing up our debugging for civil engineer. Is this under? This is on our main. So we're looking into the. It looks like one of the ones that he's printing, so I don't know if it really matters which one we do. Let's do the biggest one, since that's the one that I think. Yeah, that's a civil engineer.
We're going to hit the green button to start debugging this program. The binary is going to be set up. Once the build is good, the binary is going to be passed in our debugger, and we are going to hit our breakpoint in a minute. Let's wait for this. So we have hit the breakpoint at line 20, and if we expand our civil engineer object in our locals, we're going to see that we have an engineer part of us. We can expand that and see that we also have a person part of us.
Yep.
If we look at person, we're going to see that the full
Biggs
name
McGee,
is
Negra Arroyo Lane,
John Travolta,
32.
which is what we are passing here. We can also look at our age. The age is 51, as you see here. And we're going to also have information about our address. If we expand this, we're going to see that the address is this gibberish that we just put in. Tiny dog,
well, mine
42 straight, and number 89. We can see this information here, and you can really expand and see all these things that make up our object. For example, we can see the information about the contract count, which is 31, and it is what we are passing when we build this object here. And the speciality happens to be road strength, as we see in our locals here. You can really see all these things. We are going to stop here in this lecture. In the next one, we're going to explore how copy constructors work in our inheritance hierarchy. So go ahead and finish up here and meet me there.
Okay, copy constructors with inheritance. I think that this is a good place to call it for the day. We've gotten through about an hour of the video, which is good. That's kind of what I was hoping to do. So we have one more hour before we complete the chapter. So what I think we'll do is we'll try to do those. We got 4 more chapters, about 15 minutes per chapter remaining. I think what we'll try to do, because today is Tuesday, we're going to try and complete this chapter this week. Or this week, what am I saying? This chapter I want to complete tomorrow. I want to finish this off tomorrow. We'll be doing 4 more things, and then that'll put us at the 26-hour, 21-minute mark. But I think we did a lot today, dude. Today I think it finally started really clicking how it all works, and I'm super happy with the way that today has gone. I really enjoyed this lesson. This was great. So what I'm going to do, we're going to go ahead, I'm going to where's my C++ progress? C++ progress.txt. Let's pull this bad boy up. So we're looking at, Jesus, this is the longest chapter we've done so far, but I mean, I guess I'm not surprised. Classes took me 3 fucking sessions. This one's going to take me 4. How is the studying? We're just wrapping up for the day, but we're at 25 hours. 26 minutes and 56 seconds. We're on copy constructors with inheritance. Now, I'm not 100% on exactly how much more stuff there is to do. Lazy talking, lazy. What you talking about? CP files. Well, you see, what he's talking about are these things that we have called CPP files. But he doesn't like engineer CPP files. You know what he's saying? Which I understand. I don't think anybody would begrudge him that. Okay, but so we have this one. We have our timestamp: 25 hours, 26 minutes, and 56 seconds. I'm gonna close this bad boy. We have our copy constructors with inheritance. This is where we are in the video. I'm not sure how much more of this one file we're gonna use. This is kind of like we've been using the same one now for, I mean, 2 whole sessions. We've managed to do a lot of this. A lot of this. I'm super happy with the way we've done it today. It's finally clicking. It's fine. I feel like I'm understanding it. There's things that I'm not 100% on, things that I'm not like, things that I've heard, like this. I still don't really understand the OStream way of printing out text. Uh, I I kinda sorta, but not really. You know. But that is hopefully something that he will cover eventually. I'm hoping. If it's not explained by like the beginning of chapter 19, we're definitely I'm gonna like try to find an actual like explanation to do on stream, so that we could just as like a side quest. But for now, I think we're doing great. So I'm gonna go ahead and we're gonna save all this stuff. We're gonna close that bad boy. Close this bad boy and move this bad boy over here. So I hope you guys had a good time hanging out with me today. It's been a lot of fun doing some C++, and today especially I think has been great for it. Like learning, like it's actually, I keep saying it's clicking. It's like I'm understanding. So I'm really appreciative. I'm appreciative of anyone who wants to come and hang out with me and help explain things to me. It's been about 2.5 hours. I started a little bit late today, but that's because I woke up a little bit late, so hopefully that's not too much of a problem. I want to make an effort to, even if I wake up late or something, I want to make an effort to stream anyways, to do the C++ anyways, because part of the reason I've been putting some of the C++ off is because I struggle with sleep, and so I'll wake up. I won't be able to sleep until late in the morning, and then I'm like, oh, but I'm too tired to stream. I want to make an effort to make sure I do it at some point during the day. It's something I care about and I want to do, so I'm gonna make that effort. I hope it's not too much of an inconvenience if I stream it a little bit later in the day than I intend to. 3 o'clock is generally when I like to start Eastern Standard. If I do it later, I hope that's not an issue for anybody. But in any case, yeah, we'll be back tonight with some gaming stuff. We're gonna be doing some Resident Evil tonight, and then we're gonna do more C++ over the course of the week. With any luck, the day after tomorrow, we start inheritance, or not inheritance. Fuck am I saying? We start polymorphism, the final chapter of the C++ thing. So I I mean, at that point, I think I need to start looking at stuff to do. I need to use this shit somehow. So we're gonna figure something out with that. I will see you guys later. Have a good one. Um, get some food, whatever it is, whatever's appropriate for the time, wherever it is you happen to be. And we'll be back later tonight with some gaming, some more chilled out stuff. Later, guys. Have a good one. Bye.